Hey Trig, we are starting chapter 5, and it's one of my favorite chapters because I'm more algebraic than geometric, I guess. And I really like this section where we're taking a lot of our algebra concepts and applying it to trig. So this first part is just recall. All right, we have to recall some of these identities that we've been using. And reciprocal identities we know. Cotangent is 1 over tangent, secant is 1 over cosine, cosec is 1 over sine. We used that all last chapter as well. All these, by the way, are on page 197. Okay? And then quotient identities. This is a little bit different. We've touched on these, but I don't know that we actually have defined tangent as sine over cosine. We know that sine represents the y-coordinate, right? The y-coordinate represents the sine of theta on our unit circle. The x-coordinate represented the cosine of theta. And we knew that tangent of theta was the y-coordinate divided by the x-coordinate. So that's where that comes from. Okay, another way to think of tangent of theta is to take the sine of theta divided by the cosine of theta. Therefore, the cotangent of theta is the reciprocal of that, cosine over sine. We had learned the Pythagorean identities back in chapter 3. Okay, I still have them on the front board, but we're going to have them at our fingertips a little bit more. We've been graphing now, so we've kind of gotten away from these, but these aren't new. We learned them before. We've also learned, we know that sine is an odd function, symmetric to the origin. So the sine of a negative angle is the opposite of the sine of the angle. Cosine is even, etc. Okay, so again, this is on page, 197 in your book. But we're going to be using these identities to help us rewrite different identities in terms of each other. Okay, kind of algebraic. So here, tangent of theta is -5/3, and theta is in quadrant 2. Okay, so we're still going to have that idea, okay, of when things are positive and negative. Tangent's negative in quadrant 2. We get it. The x-coordinate is negative, the y-coordinate is positive, right? They're asking us to find each functional value. Okay, so how can I get from tangent to secant is what I'm looking at. And so what I want you to start thinking of is this identity has tangent and secant right in it. Okay, tangent squared plus 1 equals secant squared. That's an identity we haven't used in a little while. But that's where we're going to head with this, okay? -5/3 then is the tangent, so I'm taking -5/3 and squaring it and adding 1, and that'll give me secant squared. So that's 25/9 plus 1. I'm going to call that 9/9, okay? 25 plus 9 is 34. So 34/9, at least I know what secant squared is. So what is secant? Well, it's the square root of that. Plus or minus, right? I have plus or minus the square root of 34 over 3. I took the square root of 9 there. So we have to think now, which is it, plus or minus? I'm in the second quadrant. Cosine is negative there, so is secant. So now I can just erase the positive part. I know now that it's negative square root of 34 over 3. Okay? Now, some of you are still thinking in the y and x world, right? And you might say, well, I'm trying to find secant, okay? So I'm afraid that you'll start thinking, you'll forget about the r part, okay? We're used to being on the unit circle, okay? So we just want to be careful here. Okay, of how we think of this. I can't just say that the cosine is 3, okay, because 3 is down here in the denominator. It was basically x over r and y over r. Okay, so You can go back to those ideas though, if you want, and you can find r, x squared plus y squared equals r squared. That would give you your square root of 34, right? Okay, for r. So cosine is x over r. So secant is r over x. So now I could get my square root of 34 over 3 that way. Okay, and then I'd have to remember it was negative because I'm in quadrant 2. All right, so those old ways, we're trying to get you away from doing that and think more with these identities. Okay? So now, how am I going to get to sine if I know tangent? Okay, I know that tangent is sine over cosine, right? So negative 5/3 equals sine over cosine. And I have to be careful now. I found secant, so I do know that cosine is negative 3 over the square root of 34. All right, I could have found cosine, and so now I can find sine by multiplying both sides by negative 3 over the square root of 34. Cancel, right? I get positive 5 over the square root of 34. And I might recall that as 5 squared root of 34 over 34, okay, if I want to rationalize the denominator. Okay, so since tangent was sine over cosine, I used the fact, I kind of used my letter A here. Since I found secant, I also found cosine, and then I could do that. You just want to be careful that you don't think that the sine is negative 5 and the cosine, or the sine is 5 and the cosine is negative 3. Okay, it's not. I know that sine is, tangent is sine over cosine, and we just said tangent is negative 5 over 3, but there could be, that doesn't mean that it's 5 and 3. There's lots of things that, there's a lot of fractions that reduce to 5 over negative 3, okay? Cotangent of negative theta, let's go back and remember what that is. The cotangent of negative theta is the same as negative the cotangent of theta. Okay, cotangent is an odd function. Okay, they're opposites there. So this is negative cotangent of theta. Now I do know that cotangent is 1 over the tangent. So I'm going to have negative, if I take 1 over tangent, sorry, I knew that was going to happen. I could feel it in my fingers there with this pen. At least I got my pen back. So I'm going to have negative 1 over negative 5/3, and that ends up being positive 3/5. Okay, so just things like that. And it is true, we've done, this isn't too new. That's why I didn't mind that this was on, right after we took that chapter 4 test. We're just recalling some things that we've already been doing, okay? And working with it, and trying to get it, refamiliarize ourselves with that, okay? Write cosine x in terms of tangent x. Well, I know that tangent x equals sine over cosine. That's something that we can go with. I also know that tangent squared plus 1 is secant squared, right? I'm trying to write cosine in terms of just tangent. In terms of just tangent. So here, if I write cosine x, I would multiply both sides by cosine. Cosine x equals sine x over tangent. I know that, right? That didn't get me. I didn't write cosine in terms of just tangent. So I was using my quotient identity, but I can't get rid of the sine word. Okay? I do know that cosine is the reciprocal of secant. Right, so secant squared is the same as 1 over cosine squared. Isn't that true? Does that make sense? I didn't change anything. Secant squared is the same as 1 over cosine squared. So I could multiply both sides by cosine squared. Okay. And then divide by this. And now I'm getting close. Okay, we're getting close there. I wrote cosine squared in terms of tangent, but I want to write just cosine. So I'm going to say that the cosine of x is plus or minus 1 over the square root of tangent squared x plus 1. I've rewritten cosine in terms of tangent. It's not pretty, but you tell me the tangent, I'll tell you the cosine. Plus or minus, you have to tell me the quadrant too that you're in, okay? But I wrote cosine in terms of tangent, okay? There's a couple right answers to these, all right? Don't get worried. It's not like other things. There's different ways to represent your answer, okay? Write this in terms of sine and cosine, and then simplify the expression so that no quotients appear. Okay, they're just having us play with these and use our identities. Let's see, what was 1 plus cotangent squared? Oopsie, sorry. 1 plus cotangent squared. Oh, that's cosecant squared. Okay, so I remembered there was something about those, right? So I have cosecant squared. And what's 1 minus cosecant squared? Is that something? I can play with this. If I subtract cosecant squared over there, then that's going to equal negative cotangent squared. Do you see it? I subtracted cosecant, and then that's going to equal negative cotangent squared. So I could put that in there. Now they wanted us to express it in terms of sine and cosine. Cosecant is 1 over sine. Cotangent, what was that? Cosine over sine, right? They asked me, they told me specifically to write things in terms of sine and cosine. When I divide fractions, that's the same as multiplying by the reciprocal. So this 1 over sine squared, I'm going to, instead of dividing that by this fraction, I'm going to multiply it by the reciprocal. That was negative. Oh, yay. I love when things cancel out. We get 1 over cosine squared, negative. Okay, I keep forgetting my negative along the way. And 1 over cosine squared is secant squared. There. We've simplified it so that no quotients appear. All right. Now we're going to get into what we're going to be doing next, which is verifying trig identities. I'll talk about that in a minute here. When you see two things equal like this, okay, we just want to kind of show that it does equal. We want to say, and the directions here I think are to say true or false, that this side equals that side. Okay, so let's try it. Let's distribute through. Cosecant, which is what, 1 over sine? Oh, well, I'm just going to, right now, I'm just going to distribute just like I would. Sorry, let me erase this. I'm going to distribute just like I would if it was any problem that I have outside parentheses, right? So I have cosecant x times cosine plus cosecant x times sine. Gosh darn it, I'm so sorry. This is extra sensitive today. Cosecant x times sine. Okay? Now cosecant I know is 1 over sine. I'm just trying to get things to cancel if they can. If I multiply these two fractions together, I get cosine over sine.